Hello, this is Zulongye at Computer Engineering major, and now I will demonstrate the solution of homework 6 of ECE6303, question 1. First question, we need to find the A to make it a valid joint density function. We know that x is larger than -1 less than 1, and y is larger than -1 less than 1. We can calculate the integration of xy dx dy. It will be the integration from -1 to 1 here dy and -1 to 1 dx, and the function is 1 plus xy divide a. And we can calculate it and get the answer 1 divide a -1 to 1 -1 to 1 dx dy, and then plus 1 divide a -1 to 1 y -1 to 1 x dx dy, and we can get the answer is 4 divide a. To make it a valid density function, we need to set this to 1, and then we can get the answer a equals to 4. Then question 2. Firstly, we can calculate the expectation of x and y. It is the integration from -1 to 1 -1 to 1 x1 x multiply y, and then multiply 1 plus xy, then divide 4 dx dy. And we can calculate to 1 divide 4, and then the integration from -1 to 1 -1 to 1 xy dx dy, and then plus 1 divide 4, then the integration from -1 to 1 -1 to 1 x squared y squared dx dy. And we can calculate to the result. It is 1 divide 9, and then we can calculate the expectation of x. We can take the same method, and it is the integration of x multiply 1 plus xy, then divide 4 dx dy. And it is 1 divide 4, then integration from -1 to 1 x dx dy, then plus this integration x squared y dx dy. And here we can get the answer. It is 0. And we know exy is not equal to ex multiply ey. And here we know xy are not uncorrelated. And from question 2, we know xy are not uncorrelated. And then we know xy are not independent. Now next is question 4. We need to find joint density function of x squared and y squared, we can set that z equals to x squared and w equals to y squared. We can calculate the differentiation. J here 2x 0 0 2y, and the result is 4xy. We also know that z equals to x squared, w equals to y squared. They has 4 roots. Also, abstract value of x is less than 1. Abstract value of y is less than 1. We can get that z larger than 0 and less than 1. W larger than 0, less than 1. And we have the density function fzw equals to fxy zw. This is the first root. Then divide J1 m plus fxy, here is minus squat z squat w, and here's J2, and then here's x. Fxy squat z minus squat w, J3, and fxy minus squat z minus squat w, J4. And then we can calculate it. It is the 4z squat and squat w. And this is the answer of J1, J2, J3, J4, and we can get them and calculate 1 divide 4, and then 1 plus z squat w, and 1 plus minus z w, 1 plus z minus w, and 1 plus z w. And then we can get the answer. It is 1 divide 4 multiply squat z squat w, and then we can get the answer fw zw equals to 1 divide 4 squat z squat w. When z is larger than 0 and less than 1, w is larger than 0 and less than 1 here, and 0 when z and w are other values. And next, question 5, we need to prove or disprove the x squared and y squared are independent. We can calculate the density function of fz and fw. Here w is y squared, z is x squared. And the answer is the integration from minus infinity to infinity, fzw zw dw, and it equals to integration from 0 to 1 dw. And we can get the answer is 2 square z. And the second equation is the integration from minus infinity to infinity fzw dz. And here we can get integration from 0 to 1 here. 4 multiply square z square w dz. And the answer is 1 divide 2 multiply square w. Therefore, we can get fzz equals to 1 divide 2 square z when z is larger than 0 and less than 1, and 0 when z is other value. Meanwhile, fw equals to 1 divide 2 multiply square w, and w is larger than 0 and less than 1. Also, when w is other value, the function is 0. Therefore, we can get that fzw equals to here fzw equals to fzz multiply fww. And here we know that z and w, they are independent. Therefore, x squared and y squared is independent too. That's all. Thank you.